This week we have two hot questions. Questions 1 is about Kirchhoff law, whereas questions 2 is related to the potentiometer. Questions 1. Figure 1 shows a cell of EMF 18 volt and internal resistance 2 ohm connected in series with a resistor of resistance 8 ohm and a uniform metal wire AB of total resistance 14 ohm. A second cell of EMF 4 volt and internal resistance 1 ohm is then connected across the wire at point A and C. The connection at C is halfway along the wire. The current directions are shown on the figure 1. Find the current I1, I2, and I3. Now, if you look at this question, it seems like a potentiometer question, but it is not. Because point C is not the balance point, you are not given the balance length along the point A and B. So this question, in fact, it is a Kirchhoff law question. A Kirchhoff law question with two loops in it. So now let's find the current I1, I2, and I3. As usual, step 1, label the diagram. So this is a diagram given, and that is how I'm going to label it. But that is not the end yet. Other than EMF1, EMF2, R1, and then internal resistance 1 and internal resistance 2, I still have two more resistance in this diagram. Why? Because the question, it did tells you, now wire AB is a wire with resistance. Therefore, this is how I'm going to label it. I'm going to split it into RAC and RCB. Now, if RAB is equals to 14 ohm, then how about RAC and RCB? You are given C is located halfway along the wire. Therefore, RAC should be equals to RCB, and both of them, they are equals to 7 ohm. Now that we have a diagram with label, so let us proceed to step 2. Apply Kirchhoff first law. Kirchhoff first law, summation I in is equals to summation I out. So this is a diagram. As usual, I'm going to choose a junction. In this diagram, the junction is located at point A and point C. So I'm going to select point A as my reference junction in this step. So point A is my junction. If you look at the diagram, now the current moving in to the A is the current I1. And then the current coming out from point A is I2 and I3. Therefore, the equation is I1 equals to I2 plus I3. Rearrange the equations. I have I1 minus I2 minus I3 equals to 0. And that would be my equations number 1. Now that we are done with Kirchhoff first law, let's move to the next step. Step 3, apply Kirchhoff second law. Kirchhoff's second law, summation V equals to 0. So let us look at the diagram. In this diagram, I'm going to choose the upper loop as my loop 1. And I'm going to choose the top right corner as a starting point. So in this loop, I'm going to let the loops to travel in anti-clockwise direction. So let us begin now. If it moves to the left anti-clockwise direction, it will pass through the external resistor and the EMF1 with internal resistance R1. Now, as the loop passes through R1 and the internal resistance 1, it will experience potential drop. And in this case, both of them, they are going to be a negative value because your I1 and the loop, they are pointing toward the same direction. And as it passes through EMF1, since it is moving from the negative terminals towards positive terminal, So it's going to experience a potential rise in this case. Thus, we have positive EMF1. So let us continue. So there's nothing along this wire. And then next, from point A towards point B. Now remember, wire AB is a wire with resistance. In this case, we have to take into consideration the IR along wire AB. So since I split it into two R just now, so what happens in our equation is, I'm going to substitute it as I2RAC and I2RCB. And both of them, they are going to be a negative value because I2 is pointing towards the same directions as the loop. So now let us continue. So as the loop goes back to the original position, well, there's nothing more along this vertical wire. So the equation is negative I1 R1 minus I1 small letter R1 plus EMF1 and then minus I2 RAC minus I2 RCB, and it is equal to 0. Substitute the value and you will get negative 10 I1 minus 9 I2 plus 18. Rearrange the equations. I now have 10 I1 plus 9 I2 equals to 18. And this would be my second equations. We are not done with step number 3 yet. So let us continue with the second loop. As usual, let us begin with summation V equals to 0. So this is a diagram, and I'm going to choose the lower loop as my loop number 2 now. And once again, you need a starting point. So I'm going to choose the top right corner as a starting point. But now in this loop, I'm going to let the loops to travel in the clockwise direction. So let us begin. So in the clockwise direction, first it's going to move downwards. Let us move downwards. There's nothing along this vertical wire. So let us continue. The loop will now travel to the left. As travel to the left, it will pass through the internal resistance R2 and EMF2. Now for internal resistance R2, it's going to be a positive value. Why? Because my I3 is against the directions of the loop. So in this case, I will have a positive I3 R2. Then how about EMF2? Well, EMF2, remember, it does not depend on the current. You look at the terminal. So the loop is traveling from the negative terminal towards positive terminals. So once again, this EMF2 is a positive value. So let us continue. Again, there's nothing along the vertical line. And as it's moved from point A to point C, well, remember, point A and point C is a wire with resistance. So you need to take into consideration the resistance inside the wire. And since I2 is moving towards the same direction as the loop, therefore you will have a negative I2 RAC. It's a potential drop. So this is the equations. I3 R2 plus EMF2 minus I2 RAC equals to 0. Substitute the value, you will have 1 I3 plus 4 minus 7 I2 equals to 0. Rearrange the equations. I now have 7 I2 minus I3 equals to 2. And that would be my last equation, equations number 3. Now that we have all 3 equations, let us proceed to the final step. Step 4, solve the questions with calculators. We can straight away solve the questions with calculators because this question is asking for I1, I2, and I3. So let us list down the equations again. Equations 1, equations 2, equations 3. So key in the values in your calculator and you should obtain the answer. I1 equals to 0.808 ampere. I2 equals to 0.601 ampere. And I3 equals to 0.207 ampere. So that is the end of these questions. Questions 2. Figure 2 shows a cell with EMF 1.5 volt and internal resistance 2 ohm is connected to a 3 ohm resistor. The potential difference across XY is measured using a potentiometer. If length AB is 1 meter and its resistance is 10 ohm, find the balanced length on the potentiometer. So as usual, let us start from label the diagram. So this is a diagram, and this is how I'm going to label it: EMF1, EMF2, R1, R2, and the internal resistance R. Now remember, wire AB once again is a wire with resistance. So in this case, I'm going to label wire AB as RAC and RCB. In order to determine the length AC, step 2, we need to determine the values of VAC. But then, we cannot determine the value straight away because we don't have enough information. So let us look at the diagram. How are we going to determine VAC then? Well, since VAC and VXY, they are parallel to each other, therefore we can determine the values of VAC by determining the values of VXY. So to determine the values of VXY, we are going to focus on the lower loop. Now, if you look at this loop, the voltage across R2 is actually same as the VXY. So now let's see, how are we going to solve it? If you look at this diagram again, you look at the information given, we don't have the terminal voltage, and we also don't have the current in this lower loop. Therefore, we cannot solve it by using the equations for EMF. So in this case, we are going to apply potential divider equations. So potential divider equations, Vxy over EMF2 is equals to R2 over R2 plus internal resistance R. This Vxy is same as the voltage, the potential across R2, whereas EMF2 is same as the total potential across R2 plus R. And this is our potential divider equations. So substitute the values in the equations. We will then obtain Vxy equals to 0.9 volt. So VAC is equals to Vxy, thus VAC is also equals to 0.9 volt. Now that we have VAC, in order to apply the equations for potentiometer, we need one more information, which is VAB. So step 3, let's determine the values of VAB. Again, this is the diagrams that we have, and now we are going to focus on the upper loop. So once again, let us apply the equations for potential divider. So in this case, we have VAB over EMF1. So VAB is the potential across RAB, the whole wire, whereas EMF1 is equals to the total potential across RAB plus R1. So again, substitute the values into the equations and you will get VAB equals to 1.25 volt. Now that you have VAC and VAB, let us proceed to the final step. Step 4, find the balance length on the potentiometer by applying potentiometer equations. So in this case, we have VAC over VAB equals to LAC over LAB. Substitute the values into the equations and you will get LAC equals to 0.72 meter. That is the final answer for questions 2. So that's all for week 15. I will see you all again next week.